Draw your graph.
I have to figure all this out.
We're graphing that
How do you turn it on?
live in action. Welcome back to Math Buds.
3, 2,
Math Squad.
Oh, Math Squad.
That's one.
Oh, the people are the Math Buds.
No.
The show is the
It's
math.
me, Michael, Leanne, and Edgar are math buds.
You're 22.
If you, yeah, you're the math squad.
I'm the Math Squad.
Yeah.
Wouldn't I be like the squad leader?
No, he's
Yeah.
just your own squad.
Squad. I'm just my own squad.
Yeah,
I
you're your own
am actually. When
person.
I roll into places, I just do math in my head.
It's true.
Oh, Math Squad.
It didn't let me grab that.
Well, don't graph it on the graph calculator. Graph it how I showed you yesterday without.
Well, how do you do it?
Oh my god.
Don't you?
What should it look like?
-3, negative.
No, just in general, like the shape.
Like this.
Like this. Do your hand.
Like this.
This way.
Yes, sir.
Like that.
Yep.
Yeah.
Yes, sir.
What?
No, this way. It goes like this.
Oh, or like that.
Yeah, like
that.
that.
It's positive.
There's
It's
no
positive.
negative.
Which one is it?
It's that one.
Negative. What are you talking about, negatives?
It's the right one.
That
It's
one right there
positive.
involves negatives, doesn't it?
How would we get one that looks like that?
We have to have negative numbers. What do you do to do something like that?
Good place to start. I wasn't sure where we could start, but
The hard work student did for that.
it's bothering me. Can we have a negative multiplier? Is that how we get that? If you're graphing that right now, just hold on for a second. Chill. What was I gonna say? Negatives. Give me a negative number.
6.
-6.
Sorry.
Okay, well let's just go negative 2 because it's easier.
Sorry.
I don't know why I asked. Okay. If we were going to graph that, how would we start?
Do table.
Do a table. Yes, that's what we did yesterday, Jessica. We can graph anything if we just make a table. And we just pick numbers for x,
Wait.
and we plug them in, and we get y. It's -2 to the -3rd power. That's crazy. Here, I'll be your calculator. I'll save you some time. You know how to plug these in though, right? You plug your bid right there and you just type it in your calculator.
It's negative 1.25.
-0.125.
Yeah, 0.2.
Wait, times 6 though. Come on. I thought I could do it in my head, but I can't.
Negative 0.75.
Negative 0.75. And then plug in -2. See if I can beat you. 1/4. So that'd be 6/4, which is 1.5. Plug in -1. You can check my work. -3. Plug in 0. Oh, you guys can do this one in your head. Plug in 0. What do you get?
1. 1.
0.
No. Who said
0.
0.
that?
No, it's 1.
Trish? Is that you?
That was me.
It's negative 1.
You said 6.
How is it 6?
It's 6.
Oh, yeah, never mind.
This is 1. Because you go 2 to the 0 power.
Stupid.
Times 6. 6. Plug it in, you get -12. Plug it in, -4. You get, oh wait, yeah. Square it, it's 4. So you get 24. Notice what's happening to the signs. The signs of these numbers. Negative, positive, negative, positive. If I graph that, -3, -0.75, -2, 1.5, -1, -3, -0, +6, 1, -12, 2, +24. Is it doing that?
Oh, no, it's making like a...
It's going like doink, 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 doink.
Huh? Like a heart monitor. Yeah. That's what your basically really dead.
You can't have a function that has a negative multiplier.
Yeah.
It doesn't make sense.
It's poopy
It
pasta.
jumps, because if you square it, it makes it positive. If you do an odd power, it stays negative.
Yeah.
You'll never see one, well, unless it's just a sequence. You can do a sequence. They do weird sequences sometimes that have negative multipliers. I think they're kind of dumb because they're not really applicable to anything in life, so why do it? But anyway, well, maybe someone on YouTube is going to comment and be like, yo, look at this. Send a link. Negative multipliers are useful in the world. So that's not how we get that. How do we get that? What would it look like? Tony, you're on fire lately.
Me.
What?
What would the equation look like if that was the graph?
Before was it
If that's the graph,
gonna?
just pick some random numbers.
6.
6, 4, 3, 2.
6, okay. But what would this be? This one you gotta be a little more specific.
2.
Can't be 2. It would look like that.
3.
Can't be 3. It would look like that.
Negative
17. Look like that.
Negative 1.
Negatives don't work.
Point. It'd be a point. Decimal. 2.
Decimal or fraction.
1/2.
Something between 0 and 1.
I don't like this.
Because if you multiply by a decimal, what happens to the numbers?
They get smaller. They get down.
Yeah, if I do like 100 times 0.5, or do half.
50, 25.
100 times half, 50, then 25, then 12.5, then 6.25, then 3.125, and I can't keep going. But they get smaller and smaller and smaller, don't they?
Mm-hmm.
That only happens if you multiply by a decimal or a fraction, between 0 and 1. If you go above 1, what happens?
It goes up.
It goes up. If you go negative, what happens?
It doesn't work.
It doesn't work.
I don't know.
So all of these graphs will either look like this or look like this. What if it is 1? You asked that yesterday, remember? Thing?
Yeah.
You're like, let's make the multiplier 1.
That's not easy.
Give me an initial value.
Like
5. Multiplier is 1 to the x. Graph it. It's just a line. Horizontal. Oh, good. Where would it be at?
5.
Y equals 5. 1, 2, 3, 4, 5. And it's always going to stay 5 because no matter what I plug in for x, 1 to the 1,000,000th power is still just 1 times 5 is still just 5. No matter what I pick down here and plug it in, still just get 5. So is that really an exponential?
No.
Technically, no. I mean, you're not really multiplying anything. You're just chilling at 5. So why don't you just write y equals 5?
There's stuff coming in after school.
What's wrong, Tony?
I don't get it.
You don't get it?
No.
We're just talking about the rules and how if the multiplier is bigger than 1, the graph will go up. Because that makes all the numbers in the table go up. Because you're multiplying by a number bigger than 1.
Oh.
Mister, you're talking too fast.
Yeah.
Okay. I know I caught it this morning.
Sure.
Yes.
Can we go to Russian roulette at sometime?
Do you understand this right now?
Not really. That's
Okay.
kind of
Well,
like-
you understand. Say you got this, then go. Remember how we were making tables of sequences?
Yeah.
Well, we're basically doing the same thing, but now we're just using y and x. It's going to be a function. If you don't know the difference, that's fine right now. I gave you this one. Just made it up. And we said our multiplier was 1/2, right? Does that make sense? Because if I do that times a half, it goes down. If you pick anything, any number between 0 and 1, pick a number between 0 and 1. 6 is not between 0 and 1. Huh?
Half.
0,
1/4.
1/4. There's another one. So if I would have done 1/4, what's a fourth of 20 of 100? What's the answer?
20.
It's 25. And a fourth of that, ooh, that's kind of hard. I did a half because it was just easy to do. It'd be like 6.25, I think. And then a fourth of that, doesn't matter. It'd be smaller though, right? So any number you pick between 0 and 1, if that's your multiplier, what's going to happen to these numbers as you go down the list?
Gonna go down.
Which way are they going to go? Up or, are they going to get bigger or smaller?
Smaller.
Smaller.
How come it's different?
On the graph, because remember, all the graph is just a picture of these numbers. All of the graphs, where that's a fraction or that's between 0 and 1, will go down from left to right. Because the numbers get smaller and smaller and smaller for the y-axis. Right? This one would be like, we'll just erase that. Here's 100. It's going to go through right there. And then it's going to go way down to like 25 in one step. It's going to be like, it's going to go down really fast.
So, if the multiplier is between 0 and 1, it'll go down. And if it's above that, then it'll go up.
Yes, because if you multiply by a number that's bigger than 1, what happens to the original number? It gets bigger. It has to. And you can't be like 1 point, even if it's a decimal, 1.1, 1.5. Your list will still, the numbers will get bigger and bigger. So when you graph it, it'll get bigger and bigger. And I was just saying, negatives don't work. You can't have a negative multiplier. Because then it jumps back and forth and it doesn't make sense. It's all stupid. See, I'm never going to give you one where this number's negative. And you're not going to use 1 either. So the only options are between 0 and 1, fraction decimal, or bigger than 1. And they always are shaped the same way. Remember back to the work to talk about, Megan, was it you?
Yeah.
Yeah. The penny a day, and I paid her twice as much every day. By the end, she was making millions.
Yeah.
It's the same thing. It's the same. That's like this. That'd be 0.01. There's your penny for the first day, and every day it's times 2. And if you graphed it, here's how much money you get every day. It goes up really fast. Or the paper ripping. Remember the paper ripping one?
That was like half to the moon.
Yeah.
Because I was right, and you were like, no.
You Googled it.
No, I didn't. You don't know what I did and what I
She
didn't.
did it.
She just did it.
Uh,
I knew it's going to be a lot of paper. The moon's kind of far away. Oh, wait, halfway to the moon. There.
it's good.
You're like,
Estimated.
you're like, no, kill us. All right.
So,
More. Give me more. Wait, I need to ask a question.
okay.
For this one,
For that one, oh,
yeah,
it's fun.
not different, but yeah, for the
10 times 2 to the x.
yeah. Can you make a table for that until we put it right?
Yes.
So that did 1, 2, 3, 4, 5, 6.
So
Okay.
back to the original problem. Graph this.
I already did it, but I'm.
You have a picture in your head of what it should look like.
Yeah.
Yeah.
Oh, I don't know.
You gotta do this right.
Yeah, I'll be over
But you could do better.
Mr. Pocket! It's supposed to almost look like that, though, right? It's supposed to be curved more, but it's like that.
You make the table.
I made the table.
You do any negatives?
No, negatives suck.
I'm going to do a couple. So look at that.
Hey, $10 to got all those answers right.
Okay.
And I'll give you -3.
I'll give you -3. 1.25.
Yep.
Boom.
1 point what?
25.
So I did do that.
And -2 would be, see, that'd be 4. Put it on the bottom. 10 over 4 is 2, and 2 left over, 2.5. And then 5, and then 10, and then 20, and then 40, and then 80.
So you think my $10?
8 for the day. These? Plug in numbers in.
You 10 times 2.
Or just plug in 0. Plug in 0. What's 2 to the 0 power?
1.
1. 1 times 10 is 10. That's a good place to start, right? That's the initial value. And then, since my multiplier is 2, I know I can just multiply by 2 every time. That's how I was doing it. I wasn't actually plugging them in. But if you don't know the patterns, you might just actually plug them in.
What about for the negative?
For the negatives, that's just calculator. How did I get them? On my own.
Oh, you did. Are you still recording?
Hmm?
Pretty long.
Where? Just plug it in. Calculator. What? Pick these numbers. Put them right here.
Oh, you put, okay.
Oh, 2.5. Right? 10 times 2 to the -2. Type that into the calculator. It spits out 2.5. Promise.
Please graph that for me.
Okay, graph. Now, just your graphs have numbers on them.
Yeah.
Oh, that sucks. Because I was going to say, for this one, make it like every 1, make it 10, so that the top's 100.
Then we'll just make it 10.
Yeah, make it like 10, 20, 30, 40, 50, 60.
Yeah.
Makes it better. That way it doesn't just go off your graph. Because if you make it 1, 10, then it's like, you're like, oh, okay, -2, 2.5. I guess it's not bad. -1,
It's good to fix it.
5. And then 0, it's already at 10. And then it's gone.
Just
So
add an
all you
extra
see
0
is-
to your numbers, mister. Can't you just do that?
So something like that.
Can't you just do that? Just add an extra 0 to the numbers.
Add an extra 0, yeah, you can do that, and then I'll change it a little bit.
That's what I'm gonna do.
You do you, get your best picture. It's kind of like art. Make Burwood proud.
Oh, please. I'm too emo for art.
100. Whatever, you got it.
You just call me stupid though?
Yes.
Fight to me.
Don't
You know.
help you out.
Fight now.
Quick review here on, I'm about to give you your homework sheet.
Yeah, do it now, right now.
You're going to have 3 graphs to draw, besides this one. Hopefully you had something, I mean, you know what it should look like. It's just a matter of hitting the right few numbers. It should look like that.
I forgot which side is the X and Y axis. This one is Y, this one's X.
Yes. I'll help you individually on 3-7. Or I can do one example up here. There's some random stuff on here. It's good stuff though. It's all good math.
All good, man.
All good stuff. Random. Some of the equations say this.
Is it 2 zeros?
It's just two sections.
Well, I'm going to give you some ones that are not like it and see if you can figure them out. Let's watch this. If I write this equation. Maybe we'll solve for x really fast. Who's the fastest? Who's the fastest?
Oh, we're supposed to solve it?
Solve for x. Got it, Evelyn?
Is it 5?
Nope.
1.
Nope.
2.
No. Stop guessing.
3.
Come on. Zoom out.
16.
Oh.
7.
Look.
Hey, what are we doing?
Solving for x.
Wait, it's
No.
4?
6.
4?
How do you know?
Mental guessing.
Mental, no, mental math.
Guessing.
No, it's 4.
How do you know?
Choose the hypothesis. It's 4.
How do you know?
Because I'm smart.
I was hoping someone would say.
18.
Dude, it's 4.
4.
You did the math, distributive property. You did good. I'm glad you can do that. But look at
You're
this.
supposed to cross multiply.
Never.
Yes, and ever.
What does that mean?
Let me get that tattoo right here.
That's an equal sign. What does it mean?
Total.
What does it
What does
mean?
it mean?
Equal.
It's a double line. What does it mean?
Equal. Equal to. Same as.
The same as, equal to. So for an equation, what's like,
Both sides.
both sides are the exact same.
Yeah.
Oh, so look at this, and look at this.
Nigga, shut up.
Hey!
Hey, what do you see?
Hey, number 4.
Watch this, Michael.
Oh,
Solve for x, go. You have 10 seconds. In your head.
Oh my gosh.
In your head.
So dumb.
Look hard. Look hard at it.
How am I so? Oh my gosh. I did not see it.
No. Zoom out. Stop reading left to right. Just look at it.
I got it. I know why. I know why. I know.
It's because
I know.
4 is in the place of X.
Yeah, look at it. It's the exact same freaking thing. Except that's 4 and that's x. So doesn't x have to be 4 for them to be equal?
Listen, this is stupid. I don't like this. I never want to do it again.
I'm confused.
Shut your time.
I'm telling you that because on your homework you have some equations that are like that.
No.
And if you just look at the big picture, you don't have to solve it. You just need to look at it and be like, hey, I need the same exact thing on both sides, so what's x need to be? And they could be crazy. It could be anything. You could be like 3 to the x power times the square root of 46 divided by the log of
why are you
17.
talking like that?
What's log?
Because I'm doing it. What's log mean? It's a math operation. Who cares? My point here is that you can solve this if you just look at
It's 10.
it. It's 10! Ooh. Oh, but they do get a little bit more tricky. What if
Why 10?
y 10? That means it has to be the exact same on both sides, right? Isn't everything the exact same? Except that one has an x and that one has a 10?
Oh, that's the same.
So x has to be 10.
Oh.
That's it. What if it was like this? Now tell me what x is.
10.
Nope.
16.
4.
Stop it.
3.
It's 4.
It's 3.
3, yes. Good job, JJ.
What?
How did you know it was 3?
Because you subtract 4, like, hard to explain. You subtract 4 from 10, then you divide by 2.
Did you just went like this? 2x plus 4 equals 10? And then subtracted 4 and divided by 2?
Michael, turn it
Yeah.
off.
Because if everything else is the exact same, those have to be the same.
That was perfect.
Last thing before I give you this.
How did she do that?
Huh? It was just, if you have, make it simpler. Whoa.
What?
Everything on either side is the exact same, except the exponent is different. An equal sign just means I need the exact same thing on both sides. That's all it is. So in order to have the exact same thing on both sides, doesn't that have to equal 10?
Yeah.
So then you minus 4, and you have 2x equals 6, divided by 2, and x equals 3. X has to be 3. Because then if I did 3 times 2, it would be 6, plus 4 is 10, and 3 to the 10th is equal to 3 to the 10th. Remember, there's a bunch of sequence stuff on here, good review. Told you it's not going away. Golf ball drop, we did that, right? Remember the golf ball drop?
And mine
You
was
were
right.
here, were you here for that yet?
I was here.
No. I know you were here.
I said I was here.
I know.
I know.
Stab himself. We have new students. I can't remember how long ago that was. We dropped golf balls, and we measured how high they bounce. No, she said she wasn't. And it was like this. This was how many times it had bounced, and this was the height of the bounce.
Yeah.
Aisha's here. She's been here a long time.
You break it. Didn't work.
If it bounced 0 times, then we drop it from like 100 centimeters.
Yeah.
And then we just bounced it, and we measured how high it bounced, and it was like 80, and then it was like 64. What kind of relationship was it?
A very confused relationship. I think they need to go see a therapist.
Wait, are we talking about the bunnies?
The bunnies, that was exponential also.
But see, we are the therapists, and now we gotta figure out the problem. Get over it, okay? I can't find your ex, I don't know why she left, okay? That's all you know.
You know how to find the rule for that?
Yeah,
What is it? Tell me.
totally, bruh. It's all written down somewhere, hold on.
No, just tell me in your head. Like,
No,
you should be
it's 10.
good at these by now.
100.
It's 100.
Okay, it's 100 parentheses.
It's an exponential. It becomes a geometric.
No, maybe
It'd be
no.
0.8.
0.8. And then x.
Right? It's just a, it becomes just a geometric sequence or an exponential function. So it's y equals ab to the x. One of the problems is like that on here. It's just like, oh, you bounced the ball and it bounces high. It's this. It is that. Last one.
Last one, go.
How do you find the multiplier? Or what would the multiplier be if the number gains 50%?
What?
1.5.
This is old school. We've talked about this.
1.5.
Why is the water on there?
You have $100
Yeah.
every month. You
0.5.
0.5?
No, gotta make it smaller.
That would make it smaller. If you wanted to go up by 50%, what's the multiplier have to be?
1.5.
What's the multiplier?
1.5.
1.5. How'd you know?
Because it's bigger than 0.5, so it's not gonna go down, but it's on 1.5.
You put 1 in front of it, yeah, you make it. If you do 1.5 times 100, it gives you 150.
Yeet. So it's just bigger than
Are you here for that?
It's just bigger than 1.
Hasn't been very long. I'm saying, what would the multiplier need to be if you wanted something to go, if you wanted the number to increase by 50%?
Yeah. Michael, put it on vibrate.
What if you wanted it to increase by 37.2%? What would your multiplier need to be? Give you
If you want me to
increase.
By 37.2%.
No, increase got to be more than 1. Remember, we just showed the graphs. We showed the multipliers be bigger than 1 if you want the numbers to go up.
Take it on the repair.
Or is it 2.68? This is it for me, right? Can I throw this over there now?
You know what's going on over here?
Yeah, she's doing her.
You're not paying attention.
See, and then when I give you your homework list, Mister, I don't know how to do this. Well, Tony knows how that goes.
Here.
Back up by 37.2%. What do you do? Do the Beyonce, remember? Get it to the
To the
decimal.
left, to the left. Everything you own in the box to the left.
And then since you want it to go up, put a 1 in front.
That's messed up.
Yes.
It'd be 1.372. That would make the number go up by 37.2%.
So you do that every time?
I forgot the next word.
What if it's decreased
Go to the
by 70%? What would you multiply by? Do we do that?
Point 70.
No.
Yes, no.
1.70.
No,
That'll make it go up.
Oh, decrease, okay.
That was when Beyonce.
I don't think we did
was
these.
so-
Yeah.
No, we didn't.
No. No, we didn't.
We just did increase, and that's all we're gonna do today. We'll talk about decrease tomorrow.
Yeah.
I'm tired of talking, losing people. It's gonna make you work now.
I was going
Okay, can you go start one worksheet please now?
Wait, so every time it's a point, you move the point to the left?
To the left, Put a 1 in front. That's just how you make a decimal at fraction. Percentage into a decimal. 5.
Where?
Like this.
Huh?
Like this.
Not
Okay,
cool.
not